Okay, what is mean by diffusion current? The current due to the difference in carrier concentration. The current due to difference in carrier concentration is called diffusion current. Suppose we have a piece of semiconductor, okay, such that one end of the semiconductor is highly populated with electron. We have many electrons on this end, and one end is less populated. Suppose this is in A and this is in B. Since there is a concentration difference, so it means that the electron will move from higher concentration to the lower concentration, and there is a flow of electrons, so there is a current, and that current is called diffusion current. The situation can also be shown here, like we have this is X, okay, so here we have point A and here we have point B, and this is the concentration of electron, which is position dependent. At X is equal to 0, the concentration is higher. At X is equal to B, the concentration is lower. So what it means? It means that electron will move from higher concentration to lower concentration. So we have a situation like this. This is point A and this is point B. So electron always move in this way. This is X. Since electron is moving, so there is a current called diffusion current density. Diffusion current density due to diffusion of electron. Because there is no electric field, the current is only due to diffusion of electron. Electron diffuse from higher concentration to the lower concentration, which is denoted by Jn diffusion. And this diffusion current density, Jn diffusion, is proportional to the concentration gradient. Means the concentration of charge with respect to X or with respect to distance, proportional to d over dx of Qn. This is the concentration of charge per unit volume, number of charge per unit volume. But Q is constant, so we can bring it outside of this derivative. Jn diffusion will be proportional to Q into dn over dx. Now this is not carrier concentration gradient, but it actually the charge carrier concentration gradient. Where the carrier are flowing from A to B, then current will flow from B to A. The direction of current will be opposite to the direction of electron, which is the conventional current. Now this diffusion differentiation, thus the differentiation of n with respect to X is negative. dn over dx is less than 0. Why? Because the slope of this curve is negative, which indicate that the current flow in a direction opposite to the direct flow of electron, which implies that the current flow in the direction opposite to the flow of electron. Why this is negative? Because the slope is negative and this represents a slope. Now to remove this proportionality sign, we put a constant here, Jn diffusion. Diffusion current of electron is equal to dn q dn over dx, where dn is the diffusion constant or coefficient of diffusion constant or diffusion coefficient of electron. This is called diffusion constant. Or diffusion coefficient of electrons. Now this is the diffusion current density of electron. In general, n might not be a function of x. It can have a time dependency also, because at time, once the time passing, then there is a flow of electron from higher concentration to the lower concentration. If so, we can replace this total derivative by partial derivative, Jn diffusion, which is dn q partial n over partial x. Now similarly, the relationship between current I and current density is relation between current I and current density J is I is equal to J times A. So diffusion current due to electrons, so I will put N here, which is equal to Q A dN partial N over partial X. Now similarly, if these are holes, then the holes concentration is higher here and lower there, then the holes will move. So it means that there is a diffusion current due to hole, and that diffusion current due to hole, diffusion current because of hole or holes is Jp diffusion, which is proportional to the gradient, concentration gradient of hole, which is Q partial P over partial X. Now again, dP over dx, a partial P over partial X, is less than 0. So it means that the flow of current is in a direction which is opposite to the flow of hole, which is not correct. So in order to correct this equation, we put a negative sign here. So we have Jp drift, because the flow of current due to hole is in the direction of flow of holes. So we put a negative sign, Q dP over dx, a partial P over partial X, it's okay. Now this is negative, this is positive. So it means that the diffusion current is in a direction which is in a direction to the flow of hole. Similarly, if we remove the proportionality sign, we put a constant here, so Jp diffusion will be equal to minus dP, we have Q, and we have dP over dx. This is dP over dx, where dP is diffusion constant or coefficient of hole. dP is diffusion constant or it can be diffusion coefficient of holes. Now since the number of electron can be a function of both position and time. So we can write this equation in terms of partial derivative also. So Jp diffusion will be equal to minus dp q, and we have partial p over partial x. From this we can calculate the value of I. So I will move to this point here, because I is related to current density by this relation J times A. So from this we can calculate IP diffusion, which is equal to minus Q A dP partial P over partial X. This is the expression for the diffusion current due to hole. So this is all about diffusion current. And in the next video we will move to PN junctions. Thank you.